determine if we record this session.
Yeah, that's fine.
Thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to our guest speaker, Dr. Ahmed Ibrahim from ECU Australia. Okay, good afternoon to our lecturers, okay, from UiTM and from ECU, okay, our beloved students, okay, from all over Malaysia. All right. Okay, for your information, Doctor, we have 14 states in Malaysia, and most of the state we have branches for UiTM. We have branches in most of the states in Malaysia. So our student is come from various states in Malaysia. Okay, we are just not from one campus. We have almost seven campuses that join us today, right? Okay,
Wow.
so welcome to ITT 320 Collaborative Teaching Program for this semester October 2022 until February 2023. First, let me introduce myself. My name is Zul Azizi Sahwi, and I'm from UiTM Rao campus, which in Pahang, Malaysia. All right. I'll be responsible for hosting this presentation today, and I'm glad to welcome our guest speaker, Dr. Ahmed Ibrahim from ECU, Australia, who will present and share his knowledge on the cloud and IoT security. Before we begin the speech, let me introduce to you our guest speaker. Dr. Ahmed Ibrahim is a cybersecurity lecturer at Edith, Cowan University, ECU, Australia, and a researcher at the ECU Security Research Institute. His research is aimed at tackling cybersecurity problems using a multidisciplinary focus on areas related to critical infrastructure and Internet of Things and cybersecurity risks in organizations. He frequently gives talks at national and international venues. He has successfully secured external grants from the Government of Western Australia and international research partners. He has had industry engagement on various projects from federal, state, and local government and critical infrastructure provider. I think Dr. Ahmed has a vast experience in this topic today, and we really want to hear from you, Dr. Ahmed. And now, without further ado, here's our special guest, special speaker, Dr. Ahmed Ibrahim. Tafadhal, Doctor.
Thank you very much. Assalamu alaikum, everyone. And thanks, Azizi, for that very generous and kind introduction. I hope everyone can hear me clearly. So as Aziz mentioned, I'm a lecturer here in ECU, and IoT is an area that I'm quite interested in as well. So I think I'll start by saying that today's talk will mostly revolve around Internet of Things and security related to it, and there'll be some overlaps and things you can relate to the aspects of cloud as well. So more IoT, a little bit of cloud in there as well. Okay, so the term Internet of Things, I don't think it's a new thing. So I'll start by explaining what I mean by IoT or Internet of Things. I will go through some of the IoT related architectures. And in doing so, I'll talk a little bit about protocols and standards that are relevant to IoT. And then, of course, the main topic where we want to secure IoT devices. So I'll start by looking at some of the threats that may be relevant to consider when thinking about IoT and security countermeasures as well. Now, IoT is a broad area, and it overlaps a lot of various categories of our lives and industries. But I also wanted to go a little bit deeper into the consumer IoT products or devices, as well as industrial IoT. Now, there are also several other types of IoT, medical IoT, and so on and so forth. But just to keep this talk limited to our time frame, I just picked those two things. There is a unit that we cover in our undergraduate course, which is called IoT and OT security. And most of these topics we covered over duration of half a semester. So I've squeezed down a lot of these things into the time frame of this topic for today, so that I can give you a snapshot into what we think about when we talk about IoT security. And lastly, I'll be doing a small demo which actually demonstrates some of the concepts that we talk about during the initial part of the presentation. And we'll also think about what sort of security issues exist in IoT implementations and what we can possibly do to actually safeguard an IoT implementation as part of the demonstration. Okay. I'm sure you can see at the bottom here, it says 47 slides. Believe me, I'm not going to bore you to death with 47 slides. A lot of those things will be pictures. So I'll be going through them quickly as well. So please bear with me. Okay, so let's think about the term Internet of Things. Internet of Things was a term that was initially coined by an MIT researcher named Kevin Ashton back in 1999. He was also responsible for the broad adoption of RFID. So I'm sure you're familiar with RFID. There's a little sensor that goes beep, beep when you go out of the shopping center with a certain kind of product with you. So that's the technology, and that's he's very much responsible for the broader adoption of that technology. Now, here the keyword of the term are Internet and Things. So, and at that time, back in 99, he was working on implementing RFID tags and sensors onto various products to track and generate data related to where they were within the supply chain. So it's a production environment. So they wanted to track where certain products were within their whole life cycle of the supply chain. So to convince his grand plan, he threw in the term Internet to make it more appealing to the executives, to convince them to actually invest in that project. So 20 years ago, the Internet was in the dot-com boom phase. So new ideas revolving around the internet, or the internet, was quite popular and attractive. So the strategy worked for him, and then the rest is history. The term has been used even now. So it's one of those big terms that we've used over the past couple of years. So though the term has been traditionally linked to very small devices and sensors that you can measure things from the surrounding physical environment, but with the adoption of internet and the vast amount of data it generates, there are so many other aspects to IoT than just those small devices. So it can be, used for ubiquitous use in various environments, or heterogeneously talking to different kinds of systems together. And we'll see some of these examples later on when I talk about some of these things later. And within the business-oriented aspect, we also expect more value out of these devices, because these small devices generate loads of data, mountains of data. So, and you would want to extract intelligence from the data and create interesting reports, or to benefit the business, the consumers as well. So those are the things that drive the IoT industry these days. And we want these solutions to be scalable at huge scales across multinational implementations, where consumers can reliably use these devices for whatever purpose they are using. And as we go through some of the examples, you know that, if you're a general consumer, you might have a specific requirement or specific reason why you are using a certain device, such as a smartwatch on your wrist. Or if you're a business that is simply monitoring the temperature in your building, you might have a different objective. You might want to bring down your electricity usage price so that your building is more energy efficient. So those are certain factors that are important for consumers these days. Okay, so here's just simply an example of the various technologies that have been integrated, and they all contribute to creating an ecosystem of products. And the definition of that in IoT, which I talked about earlier, has certainly expanded these days. This is just one example where I've just taken Google Home. I went to the Google Home website today, and I thought this was really appropriate to encapsulate everything that we consider and would be easy to relate to most of us, right? So we have certain number of sensors that sense temperature around the house. We have smart lights, smart door locks that can be all integrated into one platform where the consumer, the individuals living in the house, can view and use and consume the services that are offered. Now, what the humans see is what the dashboard only shows, and they can physically see the sensors. But obviously, when we think about the Google Home, there's so much more going on in the background. It's secretly collecting data, right? We won't talk about that right now. But of course, it's collecting so much information that are processed back in the huge cloud, which we can't see, of course. And that data is being churned through artificial intelligent models, machine learning models that makes smarter decisions so that your home operates in a more optimal state, right? So the main goal is to make sure the occupants have got a better home to live, makes things automated, and also makes it a more pleasing experience when you use these devices. So that's from a consumer point of view, what's involved. But of course, at the back end, there are so many technologies that are involved that we will, explore in a little bit. Okay, so that was just a simple example of consumer side of IoT, but of course, we now have IoT implementations across various industries, starting from at home all the way up to military, retail, medical, agriculture, and so on and so forth. So IoT is used in so many domains, and one of the reasons for the fast growth and adoption of IoT can be attributed to the availability of the right technology at the right time and development of new technologies over the past few years. So this boom about IoT is because of that. Now, based on the electronic supply chain globally, because of things such as COVID, such as the war in Russia and Ukraine, war in Ukraine actually, those external factors can slow down production, and we could see a different kind of technologies coming out in the coming years, but we'll just have to wait and see. But those are those developments in technology enable these industries to quickly adopt IoT to make things better in their environments. So when we talk about IoT from an architecture point of view or a technology stack point of view, there are various reference architectures that's being proposed. And what you see here, just one example that talks about the various sensors at the bottom here, the temp thermostats or devices that are that are physically visible for us that we actually interact with. And there can be the middle tier here, which actually can be used for communication, which is the networking stack, the protocol stack that are involved, or the various service discovery services that sit maybe in the edge or even in the cloud layer. And then finally, the services layer where you have API integration, which allows different devices to talk to each other, regardless of the vendor those products are from, or even intelligent dashboards that shows you the summary view, like the one which we saw in the Google Home. So like I said in that example, there is so much going on in the background, which we don't see in addition to the physical devices that we interact with. Now, this is just one view of the whole architectural stack. And I'll go through a few other examples just to show you that, okay, so we can actually categorize certain things into certain areas. So this is a more abstract view of the whole IoT implementation, where you have your smart things or devices on the left-hand side, and then you've got some kind of gateway device that is sitting, it could be sitting at home, it could be sitting in an organization. Thank you. That could be working as a gateway that those devices interact with, and some middleware which can be considered as API or third-party applications that those devices can interact with, where data is going back and forward, processed, analyzed, and then finally those application layer specific things which is consumed by mobile devices, other applications, or web dashboards, and so on and so forth. So this is a very abstract view, right? Here's a different view. So this is actually from something called Web of Things, which is a W3 standard, which is used by various vendors to implement IoT devices. Now, Web of Things, I'll not go too detailed about it, but it is a standard that can be used by multiple vendors when they're developing IoT technologies to make sure those devices can talk to each other, make sure those devices can talk to the cloud services various vendors provide, and so on and so forth, right? But what I want to point out here is at the local network area, we have got these devices at the bottom, like the various things like air conditioning, lights, and so on, which then could interact with something in the edge of the network. Now, edge devices or edge network, it will be a term that you'll come across when we talk about IoT. Now, edge devices are usually a central device that is more capable of handling data and doing processing that is much closer to the actual physical devices compared to the cloud itself. So a lot of processing can be offloaded to an edge device, which makes communication between the endpoint device much quicker compared to, for example, a light bulb communicating to something in the cloud. So when we say the cloud, what we are really talking about is a bunch of computers sitting in a data center that could be geographically very far from you, right? It could be in a different country, and that would make latency much higher. It makes accessing that data more expensive and more time consuming. So if you have a device that is much closer to you geographically, for example, in your organization or in the house, for example, then things can communicate much faster to that device, right? So this is again one way or one view in which you can view. So the edge device process the data, cloud device do further processing, and then dashboards can actually be used to view the result of those devices, right? How much electricity is being used, for example. Here's another example where we have a different set of technologies. So you can see here a lot of wireless signals or wireless antennas over here. And you'll notice that there's something called Zigbee on the slide here. So Zigbee is a very popular IoT-based wireless protocol that are used in very smaller devices, especially around the home appliance sector, door locks and lighting modules and so on. It's a bit of a more mature player than some of the later technologies, some of the later protocols, and very reliable as well. So this is a case where you might have these devices in a smart home environment, talking to a central console, which has a home gateway, right? Earlier I talked to you about the edge device, so this can be considered as an edge device, and which also connects to various other devices using a different protocol, in this case, Wi-Fi. So Zigbee is wireless, Wi-Fi is also wireless, and everything talking to each other wirelessly, again, connected back to this www, which reflects the internet. And then you have some remote devices that can monitor what's going on in the house. So this is not a very uncommon environment where you want to monitor what's going on in the house, isn't it? So it is very typical implementation. Here's a different kind of implementation here. So here you see over at the far left side, which is called LoRa sensor. So it uses LoRaWAN, which is a different technology, which is very different from, for example, from a use case point of view. If you think about Zigbee, it is around the house. The range of the wireless communication is, is within that sort of proximity, whereas LoRa is more applicable when you're talking about a huge area, right? Maybe some of you may be familiar with a farming area that may be very remote within Malaysia, with limited mobile coverage, for example. And in that sort of environment where you have huge land you want to monitor, you might want to monitor how much water you are giving your crops, whereabouts your livestock is moving around in your farm. So in those instances, LoRa can be very applicable because LoRaWAN has a huge, has a very large coverage geographically when we think about it. And those sensors can be very small, again, having very little power consumption and very suitable for that sort of environment. And in such a situation, you would have base stations, for example, at various locations in the farm where those sensor devices will be talking to, and a central gateway maybe in the office, which then can be connected to a more reliable internet connection. So as we saw these different views, obviously these are not physical implementations or physical network diagrams, but a way in which you can view the various stacks that are involved in an IoT implementation. So that gives us a good way of thinking about IoT from a use case point of view and how IoT devices are applicable within various environments, right? So I've already mentioned a few protocols earlier, but let's dive a little bit deeper into these protocols. So when I say protocols, what I really mean by that is, most of you who has done networking related unit, you should be very familiar with what a protocol is. It basically defines how devices communicate with each other. That's basically what they are. And this is especially very important because there are various kinds of IoT devices and a lot of manufacturers building these devices. So we want to make sure, whether it is HP or Schneider or any other vendor who is producing these devices, they should be able to talk to each other. Of course, some vendors have proprietary protocols. They want to lock into those ecosystems. That's a different case. But there are certain aspects of the protocols that help us when we want to integrate these devices into different environments. So the most popular thing that comes to mind when we talk about standardization is, of course, the OSI model, right? So we're all familiar with the 7-layer OSI model, where we have the physical data link network, transport, session, presentation, application layers developed by the ISO organization. And this view of how devices can operate in a network environment and conceptualizing in a layered approach has enabled an open approach to designing and developing technologies that makes networking and the internet actually work. So various protocols have been developed, and hardware manufacturers, software developers, they think of those devices from these aspects. And similar to the OSI model, I think something that is even more useful or more broadly adopted or considered in the networking world is the TCP/IP model, right? The not too far distant cousin of the OSI model. And we can kind of link, there are fewer layers in the TCP/IP model, and I've shown here on the left-hand side what they correspond to in the actual OSI layer. So if you're unfamiliar with the TCP/IP, it will help you kind of visualize that in that aspect. And so we have the physical and link layer, also sometimes called the network access layer at the bottom. And typically you'll have protocols such as Bluetooth, Wi-Fi, or NFC functioning in this layer. You have the network layer, which is where devices are uniquely identified using IP addresses, right? And you have the transport layer that makes sure whether it's using TCP for more reliable communication, or you have UDP if that is not an issue. You also, some protocols actually overlap or function in multiple layers, like Zigbee. It's got the networking capability. It is a TCP-based protocol, as well as some aspects of application layer as well. So you might find some protocols similar to this. And in the demo, I'll capture some traffic and also show you the actual, how it actually looks like in the packet captures as well. And then finally, we have other application layer protocols such as CoAP and HTTP. We are all familiar with HTTP. So your applications such as your browsers or apps that you develop on your mobile phone, for example, will be using these protocols when they implement those software or other things. And just to overlay that with an actual IoT device. So I've used an example such as an ESP microcontroller, which is a very common device, small computer that is used in a lot of IoT implementations. In fact, one of my PhD students used many ESPs for his actual PhD research. So this small device is very capable of doing a lot of things. But of course, it also comes with some limitations as well. But this little device, you can see the size of the thumb and the index finger, and that's the actual size of the device. That thing has got Wi-Fi capability. It has a small EEPROM that can be programmed as well to hold some code in there and operating system running it as well. So the Wi-Fi would fall, the IEEE 802.11 will fall under the physical and the link layer. And then the IP addressing, the IP version 4 addresses, 192.168.0.24, that sort of addresses fall on the network layer. And then if you're using a protocol such as MQTT, which is based on TCP, you can link it back to the transport layer and the application layer as well. In today's demo, I'll be actually showing you MQTT as an example, so we can see that very well in the actual implementation. So that's a useful thing to just help visualize how you can relate an IoT device back to the various layers of the these imaginary layers we always talk about, right? OSI, TCP/IP. How do these things actually apply? Okay, so here are some additional protocols that you might come across if you're doing some literature survey or if you're looking at different kind of implementations. And you can see how some of these protocols actually function. Now, some use TCP, others use UDP, and you would choose these protocols depending on your use case. Why are you using these devices? What's the application? Does it really need a constant connection, or can reliability take a lower priority, and so on and so forth, right? So those are the things that will actually judge what sort of protocol you use. And not all protocols are equal when it comes to security as well. Some have encryption capability natively. Others you will have to put in additional measures in place to make sure your traffic is encrypted. And I'll talk about that a little bit more later. And the messaging model is quite important when it comes to IoT devices. That is the mechanism in which IoT devices actually send data back to a controller or receive updates from the central controller. Some have got a request response model, for example, the co-app kind of services, and that kind of makes sense because it uses UDP. It can just request whenever it's needed. Whereas MQTT is a TCP-based protocol where it has a publish subscribe model. So when you subscribe to a broker, which I'll demonstrate later on, it will have a constant connection to listen to any updates coming from the actual server. So those are certain things we can think about when we consider what sort of protocols we are going to use in our IoT implementations. Now, going on to IoT standards, because of that immense growth in the IoT market, getting all the industry players and relevant organizations on the same page is quite challenging, and standardization still remains fragmented. So there's no one thing called the IoT standard. Different vendors have got different standards. Like I said earlier, vendors could have their own proprietary implementations, but these are some of the key players that you can consider. I think if you're an organization trying to implement IoT or introducing IoT into your device ecosystem, you should consider things like, is this a reliable suite of products? Will those organizations be updating these products? Will they be supporting us in the next 5-10 years as well? Will the company be around? So those are the kind of questions you might consider when you think about these standards or protocols or devices that you're going to introduce into your networking environment. Okay, so we've talked about the protocols. Now let's talk a little bit about security, right? So when it comes to security, I think when we talk about cybersecurity, one of the main things we always think about is the CIA triad: confidentiality, integrity, availability. These are very simple 3 concepts. However, it has a really, it makes it very easy for us to actually look at any situation and consider what sort of threats are we talking about, what are we trying to protect, and why do we need to protect those things, right? So if you're talking about confidentiality, that means you want to make sure anything that is valuable can only be accessed by those people who are allowed to access it, right? If you have private information, you only want to make sure only certain people who are authorized are able to access that. You don't want attackers going in there, stealing your data, and then having a data breach. So those are things related to confidentiality. Integrity is when you have data in your organization, data flowing through your network. You want to make sure what is sent from one end to the other is the same data you receive, right? You want to make sure it is authentic. Nobody is able to manipulate it or change it without correct authority. So that deals with integrity. And availability is when you need this data, you want to make sure it is available You can access the data whenever you want. If you want to measure the temperature of a server room, when you look at your dashboard, you want to make sure you see the temperature at the time that you want to check it, right? And you want to make sure that temperature is the correct temperature being shown on the dashboard so that your operator or server administrator don't panic when they see the wrong measurement there, right? So those three very simple concepts has profound impact when it comes to viewing security from that lens. So we'll talk about those things as we move forward. The problem about IoT is, the benefits of IoT is also much like like a double-edged sword. It can also be the disadvantages of those IoT devices, right? These are small devices, so cheap to produce, but that also means it has very low resources. It has limited CPU processing capability, very little RAM, and also storage is limited. You have to think about power. When you have a small IoT device in a remote farm, do you want to be walking up to that device every day to recharge the device? No, you want to leave it for months without even thinking about it. So power also becomes such an important thing. Sometimes we just take for granted, right? Those are certain things which actually constrains IoT implementation and also devices. And like I said, certain protocols have got the capability to make sure confidentiality is maintained, right? Earlier I talked about encryption. Now, until very recently, the ESP device, which I showed you earlier, it did not have the capability to implement what's called SSL, for example, right? So the SSL is the secure sockets layer which you use when you browse the internet and go to your Gmail, go to your banking website, make sure the communication between your browser and your banking server is actually encrypted so that nobody is spying on your transactions between you and the bank. So SSL enables encryption. So until very recently, this was not possible to be implemented on an ESP device, but now the later versions have got that capability. But again, that was like a hardware and platform limitation, which prevented it from implementing certain security measures. So hardware can actually limit what you can do with software. And also similarly, the environment restrictions, if you have got thousands of devices deployed in a huge area, can you really go to every single device and then apply updates to it, right? How would you deploy updates to those devices? How will you even locate if a device is broken? So again, environment constraints can also have limitations into what you can do with IoT. And then the heterogeneous nature means it should be able to interact and work with a broad number of other devices or technologies or multiple domains. You don't want to be locked into, sometimes you don't want to be locked into a single kind of vendor. So some of the IoT products that you see out there or standards that you see will show that, okay, these are the vendors we work with. And people like Google, big organizations like Google, they will promote their IoT saying that our Google platform, IoT platform, is compatible on all these brands. And if you are using those brands, that means you can use the Google IoT platform within those products. So those are things, again, that you can consider. Now, why we talk about all these multiple layers of things is that whenever we introduce all these services or platforms, you're also increasing the attack surface for any threat, right? So if you have multiple products in your organization, that means those are multiple opportunities for an attacker to actually attack your implementation. It could be to capture some traffic that is going from one end to the other. It might be confidential, right? If it is confidential information, you don't want that to be possible. Now, you might have a very important sensor. Let's imagine a port where you have ships coming into the port and then unloading your goods and then going out, right? So these are huge ships. And when they enter certain ports, there's a lot of coordination going on to make sure that it smoothly enters, docks, unloads, and then leaves in a timely manner. Now, during those when they're coming into a port, something that is very important for them is the sea level, the tide of the harbor, isn't it? So if it is low tide, certain size ships cannot enter, and it can only enter when the tide is at a certain level. So you could have a sensor that is monitoring the tide of the harbor, and if that measurement is not available in a timely manner, then the whole operation can slow down. Now, when we talk about a huge ship that is coming into a port, that is carrying millions of dollars of products, and any delay of any ship coming in and leaving could have millions of dollars of loss to an organization. So you can kind of relate to that business function to making sure that the small data that is so important needs to be available all the time. So if that were to be under an attack, somebody made a denial of service attack against a sensor, then the shipping operation could shut down, can slow down, and it could result in lots of financial damage, right? Of course, I just simplified this whole situation in just for the sake of this presentation. There are multiple fail-safe mechanisms in a real port scenario. This is just an imaginary hypothetical scenario, right? If somebody is there working in a port, they'll be pulling their hair and saying, no, this will never happen. Of course, it will never happen. It's just a hypothetical scenario. Okay, and then lastly, integrity. Just going back to that temperature example in a server room. Now, if you have a data center that has multiple servers running in, any server admin will tell you that a server room is very loud and it can get really hot as well. So that's why even Google and big companies have their data centers located in Greenland, or is it called Iceland, where it is really cold, right? So you need the temperature is so important in a server room. So if somebody is able to manipulate the temperature to say that, okay, the temperature is still fine, but if somebody turned off the air conditioning to that room and then fool the system to think that the temperature is still fine, the temperature in the server room could rise to a level that there could be a huge fire and the whole place could, just go to chaos. So that's a very small example where this sort of integrity is very important in that scenario. If you're in a hospital scenario, someone's life may be depending on the IoT devices being able to measure the information correctly and relaying the correct information to the doctor in a timely manner. So that's again a scenario where integrity is very important. Okay. So this is just an example article, which I thought is quite interesting, where the authors, Sontowski et al., it's a 2018 article, I believe, where they actually demonstrated how a gateway device in a farming scenario could be compromised. And in this situation, the gateway device was wirelessly attacked to cause a denial of service attack that then disrupted the communication between the sensors and the cloud services they were using. I'll share my slides after the presentation with Noor, so you can refer to this article later on. I think it's a very interesting article, but they demonstrated this in a laboratory environment. So if you're interested in doing a project related to that, in your university, in a lab environment, you can actually build things like this. Here's another example. It's another paper by Zaminkar and Fotohi in 2020. Now, this article again demonstrates a very popular kind of IoT specific attack, which is called a sinkhole attack. Now, in a sinkhole attack, the adversary, the attacker, is able to manipulate the routing information and fool the neighboring nodes to let it know, to make them redirect all the traffic back to the attacker. So instead of going to the actual router, it's all coming back to the attacker's machine, like a sinkhole. It's all sinking towards that, hence the name. So this could be very useful, a useful attack for an attacker if they were trying to eavesdrop or capture traffic from an IoT scenario. And even once the data is received on their device, they could manipulate it and send it back to the actual target. So there are immense applications and severe consequences if you can actually do that. So again, this article talks about that attack, really interesting article as well. I'm not going into too detail into those papers just for the sake of time. This last paper I want to share talks about the IoT security attack taxonomy. So it breaks down the various kinds of attack into the different layers that we earlier mentioned. You know, the application layer, what sort of attacks are possible in the application layer, what sort of attacks are possible in the network layer. Excuse me, like I said earlier, you know, the routing involves the networking layer. So you have the sinkhole attack in here. Physical attacks, you know, RF jamming, node injection attacks, tempering, physical damage, those are all related to the physical layer, and also some attacks that cut across multiple layers as well. So it gives us a quite interesting view of what sort of attacks are possible. Now, when you conceptualize attacks into different layers like that, it helps you to come up with a strategy to actually safeguard your IoT implementation. You can consider, okay, if I have got this device located in this location, maybe it is subject to a RF jamming attack or a physical damage attack. How will I then protect it, right? Then you do a risk assessment on the device, on the scenario, and if the likelihood of something going wrong is possible, and if the cost of that attack is high, then you have a good way to justify your bosses to invest money into putting in the required security measures to protect that device, right? Okay. Right. So I think I've covered most of the underlying topics that I wanted to touch upon. So we'll now jump straight into the specific consumer kind of devices. Now, the consumer sector is expected to grow in billions in the next couple of months. Now, like I said before, these predictions were actually made prior to COVID and prior to the Ukraine attack war. So these numbers may be off a little bit, but still the trajectory is upwards trajectory. So it's going to keep on growing. More players are going to come into the market. And of course, as consumers, we want more from technology, right? We get lazy and lazy more every day. So we want technology to help us do things more and more. There's nothing wrong with that. That's what technology is there for. But that also means that it introduces unique and interesting challenges from a security point of view. You know, when we have devices in various aspects of our lives, it gives different opportunities for attackers to actually compromise. So, you know, we talk about smart fridges. In fact, the first IoT-based attack ever was through a smart fridge. An attacker was able to hack into a smart fridge. This was a number of years ago. And he was able to make the fridge send spam emails to unsuspecting victims using a smart fridge. So when the police show up, guess what happened? They take the smart fridge to the jail. No, that's just a joke. But you get the idea, right? So when you have lots of smart devices around the house or in anywhere, it's just another opportunity for an attacker. So we can't throw away the technology. That's not a solution. Technology is going to exist, and you have to use technology. But when you understand the various threats, then you can do a risk assessment and consider how you can protect your network from various devices. So here's a different view of certain devices you might find around the house or from a consumer market point of view, and some common protocols that you might find. Bluetooth is very common. You see it every day. A lot of these smart bulbs or devices or smart toys, when you buy, the first thing you need to do to configure those devices is to connect to the device using Bluetooth. So Bluetooth is a very popular protocol. NFC, I think anyone who has an Android phone who uses that for payment, we use NFC on the Android phones. Wi-Fi, very common. Like I said earlier, Zigbee, Z-Wave, these are technologies around the house as well. And LoRaWAN, I've talked about earlier, in a large geographic area, that makes sense to use a network like that. And some of the database data-specific protocols are MQTT, CoAP, and DDS protocol, data distribution services. So they help us transfer the data from an application layer point of view. Okay, another paper that I'd like to put your attention to is, so in this paper, the authors Aladi and et al., they looked at various consumer-specific devices and explored how those devices can be compromised, and specifically from a physical layer point of view. And I'll just show you a few examples, but it's again a very interesting paper that might be worth looking at. Now, the first example I want to show is they looked at an electronic charger, electric vehicle charger from ChargePoint. That device actually had a number of vulnerabilities which they were able to exploit because the vendors, they didn't do enough security testing on the software before releasing it to consumers. And you will find this to be the case in a lot of devices. Now, if you go to CVE.org, where you can search for vulnerabilities, just search for things like insulin pump or EV charger, and you'll see vulnerabilities coming up, and they could be as far as 2019. And what's the likelihood of a vendor to actually call back all their devices because they forgot to put a patch in those devices? It's very unlikely. It will cost too much, right? So that means there are these thousands of devices in the market that are already vulnerable. So not everybody thinks about these things, but we as security guys, we always think about this stuff, right? Another example here, smart meter that is used to monitor electricity usage. Now, smart meters are physically accessible by anybody. So if you have physical access to it, the authors demonstrated that you can do an EEPROM dump from the smart meter and then trick it and clone its ID so that it will read malicious or fabricated reading on the smart meter. So your electric bill will always be very low if you do this kind of attack, right? By the way, I'm not encouraging you to do that, but the authors were able to demonstrate that in this paper. So it's quite interesting as well. So just a summary of the various kinds of attack they were able to demonstrate, and some of these things like social engineering attack, that's applicable to everything, every specific scenario. But what I find most interesting is things like device software failure, tampering attacks, eavesdropping attacks. So those are attacks that you can actually physically carry out on those devices. So quite an interesting read, and I wouldn't elaborate too much on it. I think we are coming close to the 1 hour mark. So this is the last bit of slides, right? Not a lot left. So the next bunch of things I wanted to look at was the industrial Internet of Things. So we often call it IIoT as well. So when we say industrial, we are, the term industries is very broad and often defined through from an economic point of view. But when we call industrial IoT, we are typically referring to the classical kind of industries such as the manufacturing, transport, retail, healthcare, that sort of environments. So those environments, they are kind of, they are looking at optimizing their processes and production so that they achieve more efficiency through automation and reporting and predictive analytics so that they are more optimal in their operations. So it's usually these sort of scenarios that we are actually talking about. So therefore, the IoT technologies such as sensors or communications or cloud services used, they offer great insight into the vast amounts of data that is collected, right? So if you have autonomous vehicles in a mining site collecting ore and transferring somewhere, you want to know that when do you need these machines to be serviced, right? If you have a farm and if you are pumping fertilizer into your farming area, you want to know when your fertilizer is going to run out so that you can order it in time so that it arrives in time for your production not to be interrupted, or adjusting your watering based on the weather or on the climate, and so on and so forth. So these data collected, sent back to the cloud, offers this analytical capability so that you achieve efficiency, you can manage your data much better, and make your productivity high. And also in a lot of industrial environments, safety is the #1 issue. So you want to make sure people are safe and your equipment operates in a safe manner as well. Because in some industrial environments, if you have a security breach, compared to an enterprise environment, if you're a bank and if somebody steals your data, then it's a data breach. There will be financial consequences. People will be unhappy and they'll lose customers, right? But if you are in a very high risk environment, if you're in an oil rig, for example, oil refinery, mining site, and if something goes wrong in an equipment, people could die. And that's the most serious consequence a data breach or a hack could have. So that's why in an industrial environment, security becomes security is taken very seriously because of this, loss of life or even environmental damage, right? If you have a nuclear spill, that's really a disaster. The site is inaccessible for years and years to come. So the stakes are much higher in industrial environment, and you have things that we consider as cyber physical systems. Now, this is a term that you will come across a lot if you are talking about industrial sector. What that basically means is there are humans or there's some kind of physical interaction between the cyber systems, your computers and your cloud services into the real world environment and vice versa. So things you measure like temperature or oil pressure or water limits that are sent back to the cloud, and then those things are also manipulated through those systems. So that can be considered as cyber physical systems. And the other thing you might come across is operational technology. So this is quite different from information technology, which most of us are familiar with in an enterprise environment. Operational technology, on the other hand, are things that makes automation and process control in industrial sectors possible. So that's the other side of things. So one last terminology that you might come across when you talk about the Internet of Things in the industrial sector is Industry 4.0. So Industry 4.4 are the technologies that transform the manufacturing industry through the innovations in networking, connectivity, sensors that are low cost, big data, and so on, machine-to-machine communication, AI, all of those things that developed over the years led to what we call the Industrial Revolution 4.0. So that's the Industrial 4.0. So that's a common term that you will come across when we think about this stuff. Now, when we say industrial, if you are imagining a nuclear site that is very far from us, traditionally we thought those things were very secure from cyber attacks because they were air-gapped, not connected to any internet and so on, which was the case until very recently. But attacks such as the Stuxnet attack, which was on the Iranian nuclear plant, showed that even disconnected networks can be compromised through various means, right? So that kind of brings us back to reality that just because things are remote doesn't mean they are safe. They are also subject to cyber attacks. Okay, so just lastly, I just want to mention about the smart factory concept, because this will actually help us fully appreciate how Internet of Things can be used in an industrial environment where we have sensors that are able to measure various things and that help us make decisions, interoperability that makes various products talk to each other, and also integration that puts everything into one system where you can view things in a central point of view. And also there are other aspects such as virtual reality that helps us view things virtually rather than being physically present in one location, real-time communication, even though things are geographically distributed. So this paper by Kulsum et al. Actually explores these concepts in very much depth. So I would encourage you to actually have a look at that one as well. So the architecture, when we view industrial IoT, is not too different from the rest of the things that we talked about earlier. We have the sensors, we have edge controllers, and also we have the cloud and the APIs and apps that interact with it. So you can see a pattern here that shows you have the sensors, the middleware, the cloud side, and then the applications that we interact with. So it doesn't matter what sort of industry we're talking about, it always ends up being something similar. It's just that the protocols that you use or the security threats you might face may be slightly different. So that abstraction actually helps. Now, this is a very interesting view of the CIA triad that I talked about earlier. So in most environments that we operate, we tend to think of confidentiality as being the most important thing. But when it comes to an industrial environment, maybe confidentiality may not be the most important thing. So availability or control could be even more important than confidentiality. So what does that mean? So confidentiality means you want to make sure things are encrypted, right? But in an industrial environment, availability means the services are available whenever you need it. When you turn on the light at your house, you want to make sure the bulb turns on. That's because of the power grid being available all the time. Now, someone operating a power grid would first of all care about making sure the service is available and then worry about confidentiality, right? So those security priorities help us prioritize how we put our resources into action to safeguard your implementation. So we are at the last slide, all right? So this slide simply, I just want to summarize that when you have various technology stacks, I've said earlier that it offers just different opportunities for attackers to compromise your network. And, those threats can be cyber attacks or botnets, or it could be more motivated by various reasons. There could be political tensions between two countries that leads to one nation from attacking another nation. There could be insiders in your organization that is sending you spam to actually force you to or trick you to clicking links in your email. So there could be any number of motivations. And the vulnerabilities that can be exploited could be related to your network, the platform that you use, or even the policies in your organization. So just like any other implementation, when you consider Internet of Things, it's useful to view from a holistic point of view to safeguard your implementation. So I hope that is something that echoed through everything that I talked about today. Of course, there are a lot of things you can actually enhance through those further readings, right? So I'm going to, that's all to do with the slides, thankfully. So I'm going to end this presentation here. And while I prepare the virtual machines for the demonstration, I'm happy to open for any questions. If you have any questions, just or take a few minutes break while I bring up these VMs. Over to you, Aziz.
Thank you, Dr. Ahmed Ibrahim, for the very extensive and very new to us, okay, regarding all these case studies and especially on the smart factory and the CPS, the IoT, the IIoT, okay. How about others? How about the student? If you have any questions, okay, you can free to unmute yourself, okay, with your hand, and or even you can put your question in the chat box. All right. Is there any question from the floor? Okay. Okay. Maybe I can begin with my 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 question, yeah, Dr. Ibrahim.
Yeah.
Um, Okay, just now you mentioned about LoRa 1. Okay, I just to make sure, just to reconfirm. So if we have a very big area, okay, big area of or big area to cover with our IoT devices, okay, for example, in a farm, okay, right, Malaysia, we have very big industrial in what we call it as durian. If you have heard about durian,
Yeah.
okay, durian fruit, king of fruits, right? Right. So if and then this fruit normally we plant in very remote area, okay, and then it's very difficult for us to monitor and to plug in our devices, IoT devices. So in this case, the most the most suitable network or protocol is LoRa 1, is it? And
Yeah.
then is it very difficult to set up, or is it free or with licensing to use it?
No, yeah, that's a really, really good question. And I just start with a small experience over here because even in Western Australia, I think, if you look at the map of Australia, Western Australia is almost half of the whole country. And we have like a huge land mass. And a big disadvantage is that there are so many communities that are remotely located, and a lot of these farms, like you described, are quite remote. So quite remote and large. So and you don't get mobile coverage. You have to carry an RF radio even to speak to each other in those environments.
Right.
So we in fact have a project that is currently running here in Western Australia, collaborating with our university, where we have deployed LoRaWAN into these farm areas to help with the farming and monitoring and various other things. So yes, so LoRaWAN, I think its range is about 15 kilometers. So that's really huge, and it is free. You can purchase LoRaWAN devices, quite cheaply. I don't think that's very expensive, because some of our student projects, they can afford it, and believe me, if
Yeah.
students can afford it, it's really not that expensive.
Oh.
But I think there are commercial solutions as well. I think in a production environment, you obviously need uh, things that are reliable and things that can be fixed when things go wrong. So, but I think this will be a really good technology to explore in that use case.
All right. Okay. Okay. Thank you, Dr. Hamid, from the for the answer. Okay, we're still waiting for student. If you have any question, if not, I will ask the Dr. Ahmad from the lectures. Okay. All right.
Okay.
Dr. Ahmad, can you explain? Is there any free and open source platform other than Microsoft Azure, AWS, IoT, and Google IoT? Because yeah, as what we mentioned just now, for student project, we have lack of budget, and of course, we will searching for alternative and the free one first, right? Have you encountered any of the
Yeah,
free platform?
I think that's a really good question. I think and I can see another question from Izzuddin. I'll come to that in a minute. I think from a student project point of view, there are several free tiers in both AWS and Azure as well. So as a student, you can get a number of free credit hours on those platforms to use various cloud services. So I know that in Azure, for example, from Microsoft, the Azure IoT stack can be used from the Azure student. It's not called student tier, of course. It's called, when you sign up for Azure, I think you get about $200 free credit or something to
Yeah.
use any services on the Azure platform. So Microsoft Azure and Amazon Web Services, I know that both of those uh, vendors, they have free tiers. And I'm pretty sure Google will also have, because the Google platform is quite popular among startups, because startups don't have money when they start, so they want
Right.
to use those free services. So I think that can be good choices over there. I'm not aware of any other platforms
All right.
with existing IoT platforms.
All right. So we can conclude that
So
still we need to rely on the big players to try out our IoT, right? All
yeah,
right.
that's right. So Izzuddin has asked me, is Internet of Things related to artificial intelligence? Um, so artificial intelligence but Internet of Things, let me put it this, Internet of Things definitely make use of AI, because like I said earlier, all this data that's collected by the IoT devices, if you want to make useful decisions about that data, then AI plays a huge role in making those decisions.
Correct.
So in an industrial environment, if you have machines operating 24/7 and you have IoT sensors that's monitoring the health of the hardware, and it could tell that, based on the measurements, whether it's going to need parts to be replaced soon. So it's called predictive maintenance, right? And in factories, they can do predictive quality checks to show that, okay, your production needs to be adjusted so that you can reduce waste of your production line. So those decisions are made by machine learning models that are making use of AI. So that's how I think it's related. As AI is related to a lot of things nowadays in our lives. So Shafiqa has asked from your team, Route Campus, do you suggest using IoT in one's daily life in terms of security? If says, is it worth to risk our privacy to ease our life? What a wonderful question.
Yeah.
I think so I am a security guy, so by training, I am trained to be paranoid about everything, right? So it's
Right.
really important to be conscious about privacy. But like I said, we can't run away from technology. So depending on your use case, there are safe ways of reducing that risk. So when you have IoT devices in daily life, make sure those things don't connect to things that are of value in your house, right? If you have, for example, a Wi-Fi network in your house, does your router allow you to create a guest network for your IoT devices? Can you have a separate physical network in your home? Can it be separate from your internal network where your family members are on their iPads and your IoT devices are on a separate network, right? So those are things you can consider to reduce the amount of risk. I definitely wouldn't say, the safest thing is just turn off your computer and then go back to pen and paper. But we can't do that, right?
Right.
So Noor has asked, what are some
Okay.
testing
How
tools
about, yeah, Nubatusha?
you can
Okay.
use in IoT devices for pen test? Oh,
Yeah.
that's a very big question. So I think the quick answer to that is no. Any device with an IP address, which I'll show you in my demonstration in a minute.
All right.
Any device with an IP address is just like a computer. So if you can ping that device, you can
Yeah.
identify that device. You can use your standard, pen testing tool sets to find out vulnerabilities on those devices. So that's the quick answer to that question. We can spend hours talking about it later. um, um,
Right.
uh,
How about,
so Zohair,
yeah,
sorry, what are
Zuhair?
the current dangers in the internet? Uh, there are a lot of dangers. I think it's probably a very broad question. I think if you're talking about the internet in general, consider good cyber hygiene, right? Starting with a good password and things like that
Yeah.
to consider your cyber hygiene. Um, if IT harms someone, is it consumer's fault or manufacturer's fault? You'll have to talk to a lawyer to answer that question.
Extensive forensic need to be done. Yeah.
Yes, yes.
Maybe, yeah, maybe
Uh,
because the question is about if you if we put the devices and we sell the devices to farmers, okay, they are not very like computer things, computer wise person, right? So yeah, I think that kind of question whether the blame is on the user, on the vendors or the manufacturers in terms of IoT itself.
yeah, that's a good question. You see, I'll just refer back to something I said earlier. When you are thinking about deploying an IoT solution to a
Mm,
farm or to your organization, you have to think about how reliable that vendor is, right?
correct.
Is that vendor, so just check the vendor's website to see if they even have firmware updates on the website, right? Can you actually go and update your device? When was the last time the vendor shared a recent update, right?
Mm,
So if you ask those questions and look at the vendor's website, that will tell you a lot about a vendor, how reliable they are. And so that will be a good starting point. If you just buy randomly the cheapest device and just deploy it in your environment, then that's a little bit irresponsible. So you should do your due diligence do your homework, talk to a few people, and then go for the thing, right? So if it's a production environment, you want to make sure your solution is reliable. So, I think you just wait, depending on that. If it's a student project, all bets are off, right? You can just
Yeah.
experiment as much as you want in an ethical manner.
Yeah.
So Harith, Kuala Terengganu, how does one counter a hacker, virus, or malware? Those three things require three different kinds of attacks. I'll actually show in my demo one of the things you can do as a hacker and how you can safeguard the device against an attack, right, Harith? So maybe that will be useful. Danielle, can you tell us an event where you get attacked by a hacker? You asked me, you as in I get me?
I think you based on your real experience, have you encountered any attack by the real attacker?
Well, I have been attacked indirectly, right? So recently in Australia, one of our largest medical insurance company is called Medibank Private, right? So I am a Medibank Private member, and like millions of users, our data has been stolen.
Oh, really?
and it was by a criminal organization. It was a ransomware attack, and
Okay.
they were blackmailing the company to force them to pay, right?
Yep. Correct.
But unlike a lot of other organizations, the company refused to pay. I think it's the right decision not to pay. And then they released the data into the dark web. So my data is now in the dark web. So that's a breach of my privacy. My
Yeah.
confidential information was breached. So that's an example. Otherwise, Alhamdulillah, I haven't been attacked yet.
Yeah. Alhamdulillah.
Yeah.
Okay, we have question from Najiha.
Yeah. So
Yeah.
I think we'll make this the last question and then we'll jump into the demo straight away.
All right. I think this is the last question. Okay.
Najiha asked your opinion on the future of IoT in Malaysia in the next 5 to 10 years. Oh, I think not just IoT, I think the technology sector in Malaysia is very bright and moving very fast compared to even Australia, right? I think Malaysia is very forward thinking and very much up to date with the new technologies. And you have a lot of opportunities as students to do exciting things after you graduate. A lot more opportunities in that sense, I think. So I think the future is bright. That's my short answer. And it's not because I'm biased towards Malaysia. I did my undergrad studies in Malaysia, so I feel like Malaysia is a bit like a second home for me as well.
Oh,
But
really?
yeah,
From which
but
university?
oh, I studied in Apit.
Oh,
Sorry.
okay. 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 That's good. That's good. That's good to hear that.
Yeah.
All right.
All right. I'll start by sharing my screen. My VMs are ready right now.
All
So
right.
um,
Tonight we'll be
so
having a small short demo, right, from
yeah,
Dr. Hamid Ibrahim. Okay.
yeah,
Please have a.
just a small demo. I think you can see my screen right now.
Yes, you can see.
Yeah. Okay. So here I have three windows, right? So these are three virtual machines that I'm running. So I'm using VirtualBox to run these machines. They are just three Lubuntu installations. So Lubuntu is basically a kind of version of Ubuntu, which is a little bit um, lightweight. So it is very easy to run on your computer. So nothing fancy here, three installations of Lubuntu. The one with the blue background is the server. So this will be running as the MQTT server, right? So earlier I mentioned about MQTT. So the MQTT server is called a Mosquito. broker, right? So I hope you can read what I'm typing. Is it too small or do you want me to make it larger? Oops. Oh, you see it. Okay, you see it clear, right? So
Yes.
if you want to install it on Linux, you can install this app called so just use apt install Mosquito and Mosquito clients, right? Yeah, client. So these two packages, they're the only thing that I'm using for this demonstration. So nothing too fancy here. So the one with the blue background is the server, and the IP address is 10.0.2.7. So that is my server's IP address 2.7. The green one is just the same as the blue one. The green one will be the sensor. That is the sensor that will be sending some data to the Mosquito broker, so to the server here, right? So if I check the IP address here, the IP address of my server is 10.0.2, of my sensor is 2.9. So 10.0.2.9, this is my sensor, and the red one is the attacker. I'll come back to the attacker later, right? So we can ignore the attacker for now. So, all right. So on the server, I have got the Mosquito service running. Status Mosquito. So I'm just checking that the server is running. So we can see that the Mosquito broker is the server that is running. So MQTT works like a publish subscribe model. So the server acts like a central hub, which receives all the updates from a sensor, for example, this device. The sensor could be sending something like a temperature back to the server. That's called a publish message, so pushing the message. Subscribe means anybody who is subscribed to the server can receive updates on certain topics, right? So in MQTT, when you publish things, you will say, okay, I'm sending this information to a certain topic. So this broker, the server, will keep track of all the topics. So our topic can be server room temperature. That can be a topic. Living room temperature. That can be another topic. So you can have two sensors sending data from server room, from the living room, and they all come to this thing called the server. So the server keeps track. Well, actually, it doesn't keep track. What the server does is, if anybody is subscribed to a topic, let's say I have a dashboard who wants to constantly read the temperature of the server room, then the broker, whenever it receives an update from the server room, it will send that message back to the subscriber. So I'll show it to you here. So in the installation here, we have the configuration file. I'll just show it to you quickly. So mosquito.conf, that's the configuration file. And it simply says that it's listening on this port 1883, and the IP address is 10.227. So that is this server's IP address. So it's basically listening on a certain port. That is the MQTT port, and it allows anyone to actually connect. So anyone anonymously can connect to it. So there's no authentication here. So on the client, what I'm going to do is I'll just demonstrate to you how easy it is to publish any message. So the command is quite straightforward. Mosquito pub, that's the software that you use to send data to the Mosquito broker. I'm going to tell what the host is, 0.2.7. So that's the IP address of the server, which is this one. And the port number is 1883. The topic, now I'm going to say a topic. So let's call it server room, just say server, just to keep things simple. And the message, I'll just write it on the next line. The message will be the temperature. So I have let's say the temperature is 24 degrees, right? So I just sent the message. It's not very exciting. Nothing is happening because there's no subscriber actually showing the output. So I'll just open another window so you can see what's going on. So I'll show, this is another window, and I'm going to use a command here. So let me just broaden this. Mosquito subscribe. And again, we provide the same information. Port 1883, topic server. So this subscriber is saying, okay, send me all updates related to the server. That's what this window is saying. So I just enter this. So as you can see here now, this window, it's just listening to any update. So now when I go back to the other window and then send the same command, I'm going to send the same command. You'll see an update over here. So when I send it, so you see the 24 over here, right? So what happened was this information went all the way back to the server, and then the server sent it back to this device. So that's what has happened. So just for the demo purpose, I'm using the same virtual machine as the sub-publisher and the subscriber. So let's have a look at what's going on underneath. So if I run something like Wireshark, okay, so I'm running Wireshark on the server so we can see exactly what is captured. So I've started the capture and I'll send the message again. Okay. So a few things actually happened here, right? So let's see if I can zoom in. Okay, I can zoom in. Good. So if I zoom in here, you can see that oops, okay. I'll just leave it like that. So if you look at this column, you can see a few MQTT specific fields over here that shows that there is MQTT based traffic, right? So the message I just sent was from this device. So this device is 10.29. So we can see that 10.2.9 is sending some stuff over here. So when you start sending information, the first thing that happens is the TCP handshake, right? So the TCP handshake starts from here, SYN, ACK. After that, the connect command is sent from the source. So the source is the 2.9, source is sending 2.7. That's a connect command from MQTT. And then here is the message that's being sent here, right? So the message, if I expand this, we can see over here, it's a TCP-based protocol, so that's why it is encapsulated in TCP. And you see the whole MQTT payload over here. So the topic is set as server, and then here's the message. Now we can actually follow this TCP stream because right now it is filtered. We can see, you can see over here it says server 24.1.00, right? So the point I'm trying to make here is that the information that is sent to this server is actually in the clear text. And actually anybody can send this information, right? So I'm going to terminate this command here. And I have a small script that is on the client that is basically sending random temperature values to this server under a topic called temp, right? So nothing special here. It will simply calculate a floating point number and then send that floating point as a random temperature to the server every 3 seconds. So then we can see something more interesting happening. So it's just a shell script, nothing fancy going on there. So if I go back, oops. So I just run the script in the top window. So the script is now running. Now, if I run this subscribe, we are not going to see anything because I'm subscribed to the wrong topic. So the initial script says it was sending on the temperature topic. So I just change this to temp, which is that topic, which is a different topic. So if I run it, I should start seeing, there you go. So now I'm seeing temperature, random temperature values. And if I go back to the Wireshark, clear the filter. So now we are constantly receiving that information every few seconds, every 3 seconds that information gain. Okay, so so this is the basic operation of MQTT. So now let's go to the attacker machine. So on the attacker machine, so we'll just leave this running here. The sensor is doing its job, operating normally. Now the Ubuntu attacker machine, the only thing I've done differently on this is I'm running this machine in promiscuous mode, okay? So what happens in promiscuous mode? In promiscuous mode, it will allow the VM's network card to listen to all the traffic on the network. So because all these 3 machines are on the same virtual network, my attacker machine can actually sniff the traffic between the server and the client. So if I ran Wireshark on my Ubuntu machine, on the attacker machine, and if I ran the traffic, so we start to see the communication between 2.9 and 2.7. So I'm a different machine, but now I can see the communication between these 2 devices. So what's the problem with that? The problem is because MQTT is, first of all, not encrypted, my attacker machine can actually see the payload in clear text. So if this was something sensitive, it's breached confidentiality already. Now, because MQTT can be implemented with or without encryption, the attacker machine can sniff this traffic and see it in clear text. So that's the first problem, right? Now, I'll show you the second problem. So the second problem is if I know, because I can run the Wireshark, I can identify who the server is, right? So I know that 2.7 is the server. The attacker knows this. And I know that it's using 1883 port number. And we know that there's no authentication. So all I need to do is just push any message to this server. So if I keep sending random messages, right? So if I go back to the server, we can see that, the server is already receiving the funny topic, right? Because the server doesn't care who sends the data. As long as it's receiving the data, it will just accept it. So I'm sending this stuff to funny, on a topic called funny. So I know that I can do that attack. But now what if I actually send it on a legitimate topic? So I know that the client is using temp topic to monitor the temperature. So have a look at this window, right? So when I send this, it immediately received that. Okay, so I have injected fake data into the client. So this is very obvious sending hello, but if I was a really smart attacker, all I would say is now the temperature is 100 degrees, right? So you can see on the client side, it's saying the temperature is now 100 degrees. The server room operator is going to go into a panic mode, and then bad things can happen, right? So that's just a small example of using this approach. You know, if you implemented MQTT the wrong way, an attacker can do something like this. And this is just a small, very simple example. Now, as a solution in the server side, there is actually a solution. So the solution is to use authentication. So I'll quickly show you, this is very easy to implement. So right now, the configuration file shows that the anonymous is true, right? So before the presentation, I have already created a user. So I'm going to update the configuration file to actually use the user. So I have another config file, which I'm just going to use to update it. So sudo cp mosquito.off mosquito.conf. So now the configuration file has got a few more lines added to it. So all I've said was don't allow anonymous connection. Instead, use an access control list and a password or the user accounts for the service. So when we have a look at the access control list, we can see that, okay, we have a legitimate user called MQTT user, and the user is only allowed to read and write onto a certain topic and read a certain topic. So this is called an access control which validates, authenticates the user, and also authorizes the user to do certain things. So if I restart the service, so I just restart the service. I forgot to put sudo. Now, if I go here, you see that my earlier script is now not working. It says connection is diffused, not authorized, because my earlier script did not have authentication. So in order to, and if I tried on the attacker machine, I can't carry out the attack anymore because it says not authorized. So that's the benefit of authorizing. So I can only attack if I had the correct username and password. So user, I know that, oops, what was the user? CL. Okay, so there is a user called MQTT user with password. This is a very secure password called password. So if I do that, now I can subscribe, and I can also publish using that information. Let's try it again. User MQTT, so password. By the way, this is a bad password. Don't use this password for your passwords, right?
Right.
Oh, I used the wrong topic. Okay, there you go. So we can see it's now active, right? So just a small example to show that authentication. If you add authentication to a very simple protocol, you can mitigate this kind of attack. But still, the encryption is not there, and MQTT allows you to implement SSL for encryption, and if you implement that, you won't be able to see the payload in the traffic when you use Wireshark to actually capture that. So I think we will just end the demo there. I'm happy to share any additional notes if you're interested in the demonstration when I share the slides. I hope that was useful. I think we have gone a little bit, we're almost in the time limit. Okay,
Yeah,
it's fine. Okay.
just in time. It's okay. Wow, it's very good. Very interesting and very impressive demo from Dr. Ahmad Ibrahim. Yes, sure. We are most welcome any of the slides and the demo materials that if you can share with us, Dr. Ahmad.
Happy to do that.
All right, thank you very much. I think we already almost reach the end of the program. Okay, thank you, Dr. Ahmad Ibrahim, for answering all those questions and the demonstration for us. Okay, and then with the excellent presentation, it was pleasure to have you with us with UiTM Malaysia. So the demo concludes the webinar. Okay, if you have any question, okay, you can always, I think you can always, I will share, can I share your contact details after this if the student have any question, or maybe you can pass the question to your lecturers, okay, then we can help you to get the answer from the speaker. Thank you all for your attending. Okay, we hope you have learned and enjoyed this presentation and the demos. Okay, I think that's all for today. Thank you very much. And before that, can we have a photo session with the speaker and the students? Can we have okay, please open up your camera, guys, students. Kenapa?
Oh, wow.
Ada orang webinar kat luar. Ada orang webinar kat luar. Ramai. Itu ketiga tu.
Okay, you can see here, Dr. Ahmed, these are our students from Malaysia. I think you are already familiar with all of us, right? With our faces and our
Hi, everyone.
environment.
There's a lot of you there. Wow.
Yeah. Some of
Some are
them,
big groups.
some of them are in their college, some of them in the classes, some of them in anywhere. As long as they watch our webinar, it's fine for us. Okay.
Oh,
Okay.
thanks for having me. I'm really pleased. There are so many students here and having an interest in this topic. Yeah.
Yes.
Thanks for inviting for this session.
Yeah, sure. For your information, we just reached the maximum number of 140 students for today's webinar. Okay. All right. First,
Okay.
okay, with the I count it 1, 2, 3. Then we can have a photo shoot. We can have a screenshot. Okay. Okay, with the count 1, 2, 3. Okay. Right. Okay. Next, maybe you are in the next slide because we have 130 students right now. Okay. Okay. I count again. 1, 2, 3. Got it? Okay. Okay, next. Okay, 1, 2, 3. Okay, all we got your very beautiful picture right now. Okay. Okay, thank you very much, Dr. Ahmad Ibrahim, to have you with our student with UiTM. Hope to see you again and happy holidays for upcoming Christmas and New Year holidays, right?
Uh, same to you and everyone. Thanks a lot.
Okay, thank you, Doctor.
Okay.
Assalamualaikum.
Waalaikumsalam warahmatullah.
Have a nice day. Take care, all.
Bye.
Bye. For the student, you can leave and get your attendance with your own with your own lecturers. Okay. We don't provide attendance here. Please ask your lecturer. Thank you.